Muy buenos días a todos los asistentes, profesores y estudiantes y público en general. La Universidad de Guanajuato les da la bienvenida a todos. Bienvenidos a la segunda conferencia del treceavo ciclo de conferencias de Ingeniería Civil. En este momento estamos por iniciar con el agrado, el gusto enorme de escuchar la conferencia de la doctora Lama Omar con la ponencia From a Lab Scale of Material Synthesis to Their Application in Operational Projects. Voy a dar una pequeña introducción de la doctora Lama, su CV, su formación, donde trabaja. Dr. Lama started from November 27th until April 21 as a quality controller in Paris, as a renovation, working in the renovation of the train station Austerlitz with the same company. Her jobs consisted on preparing the documentation for the job and verifying the quality of work. The client was a train company in France. From April till now, she has worked as a project manager in the same company, and her work has been to insulate the piping and the equipment on a new constructed gas plant that will contain ethylene. Her job basically consists of meetings with clients, discuss on the site, make orders from suppliers, and present the results to her superior. This is like a brief the qualifications of Dr. Lama. She pursued a PhD from 2016 from 2019 in Iceland Laboratory, Claude Bernard University in Lyon, in France. The doctoral dissertation was synthesis of nanoparticles. I'm sorry, so not to go through all of that. By innovative salt gel method, copper catalyst, preparation for glycerol hydrogelosis, and developing a new one-pot method for inorganic synthesis under argon by using Schlenk techniques. From 2015, February to 2015, in July, she pursued a master internship in the same laboratory, and she pursued her degree in the Lebanese University and the materials team. Working as inclusion of cellulosic fibers derived from olive pomace in a polypropylene, a matrix physicochemical. This is a huge background, so we are very pleased to hear the presentation of Dr. Lama. Thank you very much, Dr. Lama. A toda la audiencia en general, por favor, no olviden que la sección de preguntas y respuestas se dará al final de la ponencia de la doctora en el lapso del tiempo que quede después de su presentación. No dejen de anotar sus preguntas en el chat de la plataforma para que un servidor se las pueda transmitir a la doctora. Thank you very much, Dr. Lama.
Thank you for this introduction. I will cut my camera just in case the connection is not very well. Let's go. So I was thanking you for the invitation and the kind introduction. I will go to the first slide. So I wanted to present as well my CV. I did my bachelor studies in Lebanon till 20 years old, and then I moved to France. So first, if you don't know where's this country, it's kind of 19 hours far from your city. It's a very small country in the Middle East, but it's worth it. Maybe you should try to visit one day. And then I did my first Master of Materials in Claude Bernard, Lyon, France. I will skip the courses part, so it was mostly about synthesis of polymers, so from plastics till aerospatial polymers. But my internship focused on introducing olive pomace in the polypropylene matrix, because in Lebanon we have a lot of olives, so we wanted to valorize this product. And the biocomposed material that we can obtain, that we see here, it's a combination between this pomace olive and the polypropylene to have a new product that can have new properties, which is mostly more flexible, different resistivity, different thermal activity. So in the end, it depends on the application. Now we can see this type of biocomposed material in automobile industry. My second master, it was in inorganic chemistry, because I wanted to be more focusing on subjects that could be more applied in research, because the material was much more about practical work. As I wanted to do a PhD, I decided to make a master too, much more about research. So it was in the same university, but a different lab, and it was about inorganic chemistry. And the subject of the thesis was about creating photovoltaic system. So it's a little bit too much of chemistry. I will try to make it simple. So actually, normally in published articles, we can find different nanoparticles that are used as cellular salts. The problem of these particles is that most of the cases they are in a powder phase, and it's much more complicated to pour it on the cellular salt comparing to a liquid phase. So what we've done during my internship is that we prepared those same nanoparticles, and in that case, those nanoparticles were zinc oxide, starting from a different reactive, and we've got this suspension of zinc oxide that was used as, well, that can be used as photovoltaic cellular. We didn't go till this application, but what was done is that we tried to see here all the parameters that changed, and we were able to see that, so what we call the quantum yield, which is how much this particle can emit in the visible light, specifically in a green light. So we saw that by changing some of the parameters of this reaction, we were having very high quantum yield. So here's the suspension prepared in the lab, and still we can see that it's not very clear, which is supposed to be. It's not 100% separated, which will make it be highly applicable. After this master's, I continued the PhD in the same lab, and actually the deal was to develop more those particles, but unfortunately, as everywhere, since the lab is more related to catalysis, so my supervisor had to introduce more catalysis to my subject, which is more about synthesis of material. So for those who doesn't know what is catalysis, catalysis is to make a reaction be faster. And the point is to add, to create a catalyst, which is the material that will make your reaction be faster. We took an example, the glycerol, for a reason that, once again, it's mostly political, because my lab is focusing on the biomass production. And when we want to create biofuel using the biomass as reactive, we create biodiesel, but also we create 10 more times of glycerol comparing to biodiesel. So in order to valorize this glycerol, we had to find new reactions where we can use this glycerol. One of these reactions is to transform the glycerol into 1,2-propandiol, which is another type of alcohol, but has much more applications comparing to glycerol. So this 1,2-propandiol could be used in industrial paintings, could be used as solvent in many other organic reactions, could be used in the electronic cigarettes, and many other types of reactions. In order to make this synthesis happen, we used our zinc oxide that I already showed to you, and we added to it copper. So actually the 3 years of thesis were about how to maximize the conversion of glycerol into this propandiol, and what are the parameters that we have worked to work on them to make this hydrogenolysis much faster with a higher yield and make it more optimized. So we had many good results. If you are interested, I invite you to go to Google, write my name, and you can see the article that we already published about this subject and the first subject of photovoltaic. After doing my thesis, so as you already said, I finished on December 2019, and I took a little bit of vacation, and then I decided to search a job in technical commercial, which has nothing to do with research, but I was a little bit annoyed from being in the lab all the time, and I decided to make something different, which can help me to be in contact with people. But unfortunately, just after COVID started, so it was very difficult to find a job, and plus to find a job which is not 100% related to what I've done. So honestly, that's how I finished in this company, which is called the Precioso, that is a company inside a bigger group, which is called Altrad. My first job was in Paris, but first I will show you a little bit about what do we do inside this company. So actually the basic market we have are, as you see in the first picture, the nuclear plant. The second picture is the big metallic structure like bridges or train stations. And both of those two, we make basically painting and surface preparation. So I will show you later what do we mean by surface preparation. The third picture is from the big tanks. So here is where we are mostly, like our market is about doing insulation of piping. And the fourth picture is offshore plants where we can do both of work, painting and insulation. And here's the group that Precioso make part of it. So it's called Altrad Group. This is the businessman that created it in 1985, and now it's an international leader for industrial services for everything related to construction and especially scaffolding. So it can have many types of sectors, as I already showed you, oil and gas, electricity, environment, but he is really famous for construction and specifically for scaffolding. So here's a small place where Altrad exists, and basically it's everywhere, despite America. I don't really know why, but it exists in 224 countries, mostly in Asia and Europe. And I wanted to talk a little bit more about him, but I already found that he seems to be known in Mexico. So if you are interested to know more about his business, you can read the EY Mexico blog and you will find more information. So to go back to what do we do in Precioso, so as I already told you, it's we do industrial painting. So when I say we do, it's just we apply. of course, we have many providers for paintings, but we just apply it. Surface preparation. So when actually to be able to paint, first we have to prepare the surface. Because if we have a metal which is already painted and we want to add a new painting on it, we are supposed to remove the old painting and make it be, well, perfect or less perfect. It all depends on what does the client ask. So the first step is the surface preparation, and the second step is the painting. We do the insulation work, so I will talk more on detail about insulation work when I will show you what I am doing right now. But mostly it's, as the title say, it's to insulate piping from the outsider temperature or environment. Also, we make passive fire protection. So now we have more than one type of products. Basically, it's painting, but now many other providers are preparing a different type of material that could be used as fire protection. And basically, it's those type of material that I already talked about, like that we studied when we were doing masters. It's mostly polymers that are modified and that can be used to, in case of fire, your structure can wait like 30 minutes before being totally on fire. And to finish, we do a lot of scaffolding work, or to apply it in our sites, or we just sell it for other clients. So for all those reasons, the market is very large. We have basically everything related to fuel. So Total, which is the French fuel company, ExxonMobil. We also have or the train station company, SNCF. EDF is the electricity of France. So as you can see, our clients are from different markets. So oil and gas, energy production, and of course, construction. First, we were working almost in every country in Europe, but since we joined the Altrad group, and as he is already present in most all the countries, so he kind of divided the work by companies, because he also has many other companies that do the same work as us. So for that reason, now Precioso is much more focused about Europe and specifically about French projects. So in France, we already have more than 8 big projects. One of them is for the Eiffel Tower. So the Eiffel Tower is under renovation as well, because as you know, on 2024, France will be sponsoring the Olympic Games. So they are trying to renovate everything in Paris. So another big site that they wanted to renovate as well is this train station of Austerlitz, where I was working as a quality manager. So to talk a little bit about what did they want to do, the aim of the project actually is to renovate all the metallic structure. So if you can see here, it's basically metallic, and upstairs we do have this glass part. And well, now I just took a picture showing the inside of the station, but it's a huge. I was trying yesterday to find the exact surface, but I couldn't find it. I assume it's maybe 2 times bigger than a football pitch, just to help you imagine how much work. And to talk a little bit about numbers, so just our work, which is once again surface preparation and painting, it cost the SNCF, which is the client, 18 million euros for 1.5 years of work. So you can imagine how much all the project cost for SNCF and the government. This is, well, I chose that picture as well to show you the scaffolding. So actually it's, let's say our cousin, because Altrad has another company that is 100% specialized in scaffolding, and this company made the scaffolding for Austerlitz. And just for the story, during the COVID, many sites were closed, and actually the firemen used to come here to make their trainings because it's a very big structure and well, very, very nice for the training. That was the small story to keep the people awake. Well, we will come back to my work. So as a quality, my first object is to send the documentation for the project. So when I say documentation, it's quality plan, method of statements, and security and environment plan. In France, before starting any project, we have to send many documents, and those documents should be approved by the client, and that's considered as the green light to go and start. So that was the first step as a quality work. Then we can, if we have some products to test on the structure, we are supposed to make the test with the validation of the client. If the client sees that the product is not very efficient, he can ask to substitute it or to use another method. Once we validate everything and we start working, so my duty as a quality controller is to go on site and check that the work is well done. And to do that, we have many equipment. We will see them in the slides after. And I have to send reports for the client to show what was done and to validate together all the steps during all the phases of the project, actually. What are the main restrictions of this project? Honestly, the number one restriction was the presence of lead. So the lead is a chemical element, once again, chemistry coming back. So it's the PB, if it's easier to see. And asbestos, which is also a chemical product. And those two elements, a long time ago, I think since 2000 or even a little bit before, they are not allowed to be used in painting anymore. So these two elements used to be added to the painting because they give the painting much more sustainability. And well, before there was not a lot of tests done, so people could use more or less what they want. So this presence of lead let the public health organization and inspection work come much more often to see this site, and that was one of the reasons to let the site be and the work be closed much often. I don't know if it's in the same in Mexico, but here in France, those organizations have the authority to say, okay, now we stop the work because you have many issues. So that was one of the biggest problem. And another one is that we don't have that much space considering all the number of subcontractors that exist on site. Because as I told you, they wanted to renovate everything. So we were just focusing on the metallic structure, but there was other people that had to work on the stones. So here, if you can see, the stones are a little bit yellow. So they had to renovate the stones. They had to renovate the wood part of which is upside the metallic. They had to change the glass. So it was a very big project, and we didn't have the space to put all the equipment on the ground floor. So yeah, so to sum up, that was the main restrictions. And to finish about the restrictions here, just out, like if you look downstairs, I don't know if you can see the small light inside the scaffolding. Actually, this is the subway that was still ongoing. So we were supposed, just for this area, we were supposed to work, and the subway can still work. So we had to respect a maximum of weight inside the area. So here's the zoom on the inside of the area. And when I say this metallic structure, so that's how it looks like. And here, actually, they already started the work. That's why this structure is already painted. But basically, it's brown, and it had to be prepared and painted after. And all those white blankets are here to assure that the lead will stay inside these zones and will not go down to the ground floor. So here's the picture of before and after. So as you see here, the before, that basically nothing was already installed. And when we started to make our installation, maybe in 2 weeks, we already had all those equipment on site. And still we moved much more. So if you can imagine how it had to be after other people or other companies came and share as well their own equipment. So basically the equipment are the sandblaster, which is right here. So the sandblaster is the machine that we use to prepare the surface. We will see it later in another slide. The vacuum machine, so it's this big gray machine here, which contains big bags, thank you. And inside the big bags, we can have everything that we will evacuate from the site. Electrical connection to be able to send the granulate directly to the zone, compressors, bath installation to be able to remove all the lead problems, and of course containers to store painting and all type of materials. So here a zoom on installation. So actually this big red tube that we can see here is connected immediately to the vacuum cleaner, and the work is done. Yes, Altrad is also working on the Notre Dame. I've seen a question. So all those sand or what we will remove from the zone where we are working goes immediately to the vacuum cleaner. Here's the sand blaster. So if you can see, I zoomed a little bit. So actually, this big hole is where we come and we put inside the granulate, the material that we use to make the preparation. And this is the sand blaster. And actually, it has to make all this way to go up to the area where we are working. And here's also a small installation inside the area. So as well, we had to put mostly shower because when the worker will finish, they have to take the shower to be sure that they will not bring any chemical or any pollution with them to the outside, which is supposed to be clean. So now I will explain a little bit more about what is the surface preparation. And yes, that's me inside on this picture. We've done a training to see by ourselves how does it work, and believe me, it's very hard. So we have typically two types to make the surface preparation, or mechanically or chemically. And as I said, it depends on what is the final solution or what do we really want. And accordingly, we will go to say, okay, we need a good addition of coating, so we just need to prepare that much the surface. Or if we would say, no, we need something very perfect, so in that case, we do much more. And so for talk about the mechanically, the most common way is the dry abrasive blasting. So this abrasive blasting is what we use mostly in all the cases. It's not the cheapest, but it is the fastest for sure. And some of those abrasives can be reused, so it can be recycled. The water blasting come as a second way. It's known when you can more or less evacuate more easily the product. And of course, you have hand tool cleaning, but those are not really common, and they are much more specified in small areas. Now I will show you on the painting where do we use this type of cleaning. So actually, this is how the surface of the train station looks like, the metallic structure. As I told you, it's the clients who define. Well, of course, when they ask for doing the project, they ask the opinion of the experts, and then they decide together. But sometimes it's you can go for the perfect solution, but as it's as usual the most expensive, you just don't do it. So here, for example, everything that is in red is supposed to be less well prepared because it has a big structure. So the metal here can, let's say, can have less rigidity, and it's not going to affect the structure. Well, you are engineers, you can understand it more than me. Everything that is in purple is much more small, and if you come and you clean it by those sand blasters, that may affect the structure. And if you don't have good sand blasters, they can even destroy those metallic pieces. So you have to be very rigorous and to pay a lot of attention. And here, actually, it's a little bit hard to get it. I don't know if you remember the picture, but when you do the scaffolding and all the preparation, it's a little bit not accessible, actually. So here you can go with the hand tool to prepare the surface. And that's what I said when I was saying if we need it perfect or we need it medium. So as you can see, the most you give material, so the most you put the granulates or you try harder, the most your surface will be thinner. And this orange, all those orange dots inside, actually, there are the lead elements. And to check all this stuff, now there's many type of equipment. We will see them in the slide just after that. So once the surface is prepared, now we can go for the painting. The most common way of painting in industry is the airless spray, because once again, it's the fastest and it's a good optimization of time and cost. So the main restriction is that you need well, people that are painted already, and that they don't put a lot of material on the same spot. And actually, another disadvantage is that you have to, it doesn't give you the big, like the best type of quality, so you have to do it yourself or with a brush or something like that for all the, let's say here in the corners or all the parts where it's not very accessible. But in general, for big surfaces, that's what we apply. Need to drink, sorry. So here's an example of chemical products to prepare the surface. And the company from where we purchased this product, it's Dumont. It's an American one. And actually, this is the second type. If you don't want to do it mechanically, you can do it chemically. One of the big advantages is that you just have to apply it. So you come, you apply the product, and then you leave it for 24 hours or 48 hours, depending on the structure, depending on the type of product you used. And after this time, you just come and you remove this product. Unfortunately, it doesn't work everywhere, and it doesn't work all the time. So if you see this picture on the right, there's a big spot where we succeeded to remove 100% the old painting, but then there's all those parts on the left and on the right where we can see that the old painting is still here. So as a quality controller, you should also do a pre-qualification test. So this test is about everything we saw just right now, but to make it validated by the client. So here, you should take any piece of metallic structure that is the most frequent inside your project. You go and in the presence of the client, in the presence of external controllers, you come and you do the work. So you do the surface preparation, you validate, you do the painting, you validate. And in order to validate, I'm not going to enter in details, but there are many equipment. The most famous company is Alcometer to do all those checkups, and it's basically about a humidity test for surface preparation, for painting thickness. So there are really a lot of certifications to be given in order to validate your process. Here's an example of the calibration certificate that you have to show when you are using those equipment. And of course, when you buy your painting, you have to have a trade certificate or like a guarantee. So in France, the most important or famous organization for painting work are ACPA. So ACPA is the one that gives the controllers all the training mandatory to be able to say that this surface is well prepared and this painting is fine. And the OHGPI is the organization that gives the company the guarantees. So, well, unfortunately, since there was a lot of, as I told you in the beginning, problems, so we were stopped many times during this project. And well, I negotiated to move because as a quality controller, if there is no work, basically I didn't have work as well because I already finished my documentation preparation, and we stopped at the time where we were supposed to have more work. So I asked my superiors if I can go somewhere else, and they said me that there's a new project in the south of France for installation that time, and that I can manage the project. So that's how actually I arrived here to this small, lovely city in the south of France. And here the project was about the construction of an ethylene tank for the final client, which is called Chem1. And a little bit of introduction about the ethylene. So it's a chemical product, as you know, and it's supposed to be used in many reactions. Actually, Chem1, it's the number one company in the production of PVC, the polymer, and the ethylene is the first reactive in this reaction. So Chem1, as a strategic move, decided to stop buying the ethylene and to have it on site. So they decided to build this tank to be able to stock a big quantity of ethylene inside the tank, and then since they have all this fabrication unit in the same place, so by using those piping, they can send to their unit the ethylene that they need to make their own reactions. So once again, it's a big political project, and Chem1, due to that project, was sold to the Apollo group from the USA, which is also a financial businessman who just bought Chem1 a few months ago after this ethylene fund. So here I will give you more names because I think it's more interesting for you, since many of those companies work in engineering. I didn't do the same for Paris because in Austerlitz it was mostly French companies and they don't really work in engineering. But here you have Tissot, who worked for the construction of the tank. So Tissot is a big French company that they exist almost everywhere in the world, and they are very famous for the construction of tanks. Our first client is Sener, and Sener is the Spanish civil engineering office who has actually all the contracts. So Sener and Tissot shared the contract, and they had subcontractors for each type of job. So Sener had all the mechanical work and the civil engineering work on the site. Eiffage is also a French company, and they used to do the routes for the roads, the normal roads, but it's been a few years they are having much more civil engineering work. So if you are interested, here are some companies that may be helpful for you. And Caldererías is also a Spanish company, and they are the one who constructed the piping. And our scope was to insulate all those piping that you can see on the picture and other equipment. So when I say insulation, it means once again a new product and many techniques. So here is some companies where we have our products. So Kingspan, which is a Spanish company for the insulation products. Saint-Gobain, which is a French company, and it's also insulation, but it's not the same type of material. Well, I've put kind of all our suppliers. So if you are interested, we can even speak later about what do they do and how you can get in touch with them. So as a project manager, this is one of my duty to get the best deal from those suppliers. And believe me, it's very hard, specifically here, because, for example, Temati, which is the American company to sell the adhesive and the glue, doesn't sell directly in France. So you have to pass by distributors. And most of the time, those distributors, they try to take a lot of commission, and it's very hard. So the second big duty is to make all the delivery on time. For example, for methyl products, so EWR and Arcelor, they have at least 6 weeks of delay to be able to send you what you ask for. And when I say metal, actually is the jacket that we see here on those piping. So this is a jacket, we don't buy it done, we just buy the raw material. And in our workshop, we make it on measurement. So we have to take in consideration the 6 weeks of suppliers, and then we have to take on consideration also our time inside the workshop. I have to write weekly reports. I have to respect planning between also the co-activity and deadlines. Plus, we have to, of course, as every project, to manage the budget and try to find extra work on site to be able to have higher financial revenue at the end of the project. So here's a picture about those products. As you see, the Kingspan polymer, it has nothing to do with the Saint-Gobain, and actually it depends on the type of insulation. So the ethylene is a gas or a liquid, depends on how do you want to stock it, that has minus 100 degree. So you have to make an insulation for cold. In that case, you will use this type of insulation. But if you have a product that is an opposite hot, you should use another type of insulation. I want to show you a little bit of the difficulties that the insulators can have. So actually, first of all, they have to wear specific protection because unfortunately, all those products are toxic. So as you see, the mask is very complicated to have it all the day, and also they have to keep the suit when they are using those products, and of course the gloves. Another difficulty is that for equipment, we already purchase those material pre-ordered, pre-cut, and sometimes it's hard to find. It's like a puzzle, and well, it's not always convenient when you have a big equipment. And third, and not the last but not the least, is the co-activity problem, and that was really a big issue in this on this site because I don't know, it was not very well organized. And here, for example, we see those people doing welding work while we are doing insulation work, and of course welding can project fire, and the material could get fire, and yeah, without any protection, well. So actually in this project we had two big market, scaffolding and insulation. Now I will talk a little bit about scaffolding. First point about scaffolding is in case of a specific one. So when you need to put anything on the scaffolding, you have to make a calculation note. So the calculation note, it's something like that. You have to draw your scaffolding. You have to say how much it can have as a weight on it. You should take in consideration the wind, all the weather conditions, and once you get all the picture kind of clear, you take this plan and you make it happen on site. So this plan, we made it for the storage area on the site, and well, you can see that we kind of respected this calculation note. Basically, is to see where do you have to put more scaffolding, more material to be able to contain all this charge, all the weight of this white blanket to protect. So this is actually what I was telling you, the jacket. This is how it looks like. So it's like the piping, but of course, different type of metal and cut in small pieces. So one of the things is that it's a physical work, actually, scaffolding. It really needs a lot of energy. And of course, you have a higher accident risk because when you go, well, it's a work that's always on height. So you are always more affected by risk. This, for example, this scaffolding is done on the tank on 30 meters of height, and the scaffolding itself is 12 meters. So actually the worker has to be on 40 meter on height and 10 meters in the space, which is like has nothing surrounding him. So for that reason, they have different personal protection equipment. Here we can see it in the picture. They are really not allowed to make any movement on the scaffolding without being attached. Of course, once the scaffolding is done, there's a green card that allows the access. And in the time when it's under construction, it's always a red card. And the team leader is supposed to make a daily inspection to check that nothing happened to the scaffolding. And that was not the case at all in our site. Due to the co-activity, you always come and you see that your scaffolding, I don't know, it has a piece missing or something happened to it without any prevention. So that was the job and the site. We're still here. It's not finished yet. We're almost about the end, but as everywhere, they are having some problems. So maybe it will take a little bit more of time. And after that work, so my upcoming project is the installation of this valve. So here the client will be Storengy. This is the gas company in France. And it's a very different project. I've never worked on this type, and I actually have no idea. So the point is to make a new installation matrix, which is from different material, because we're always used to work on polymers, something like that. Now it's more rigid. So the client asked to build kind of, as you see, a room surrounding this valve. So we will have electrical subcontractor, civil engineering subcontractor, and if this project works, this company has much more other valves to insulate, and that will be a good beginning for our company in this business. So I really feel the tension, but I am happy that they choose me to do this project. And at the end of my presentation, I would like to say for all the students that if you don't feel very comfortable in what you're doing, just do what you want or what you wanted to do, and remember that you never lose, or you learn, or you win. So thank you for everything, and if you have any questions, please don't hesitate.
Thank you very much, Dr. Lama. It was so amazing to hear you, and to all this final speech that you gave was all these quotes are certainly will be helpful for, I mean, for the students. It would have been helpful for me when I was some years ago.
Well, I hope so.
Thank you, thank you. Well, we have several questions. There's one around here regarding to the construction of the Notre Dame Cathedral. There was a big fire back, like I think 2 years ago or so.
Yeah.
So, well, actually, this student, Victor Alfredo Zarate, he's asking whether Altrad is involved in the reconstruction of this cathedral of the cathedrals. So this big issue, and if so, what do you think is the solution provided for the burned wood structure? What do you think?
So yeah, actually they are involved. Many companies are already tried to help, and Altrad gave, well, I'm not sure if it was 100% free, but with many reduction, let's say he offered the scaffolding.
Mhm.
And the main issue was, well, you saw the news, it was like all the top was already burned. So now what they are trying to do is to renovate what they can, but then to make like a new part, which is which was unable to be saved. There's no real magic in it. It was a total accident. Like it could be not done, if you see what I mean.
Yes,
There was
yes.
a technical, yeah.
It was not an anticipated issue that you could be dealing with like easily. Yeah. Well, thank you. Well, Dr. Ramon, he's asking us to share this question to you, with you.
Mm-hmm.
What considerations should be taken when coding is applied in all structures? Yeah, very interesting question. Where a variety of materials are present, like wood, glass, or steel. Yeah, this is a very interesting question. What do you think?
I'm not sure I listened. So what are we supposed to do when?
Yeah. Let me rephrase the question. He's asking what considerations should be taken when a coding is applied in old structures where there are different materials like wood,
Ah,
glass, or steel, like a
yes,
combination. Yeah.
yeah. Actually, so for example, in Austerlitz, we were in a group with another company, and this company had to remove all the wood. So it's because it's totally different technique. When I say surface preparation, it's 100% for metallic structure. Everything which is wood or glass or other type, it doesn't enter into my scope of work.
Great, thank you very much. There's another one. Well, I have myself, but I will leave it for like afterwards. But how was this Oscar Martinez is asking how the current natural gas crisis affects the ethylene industry. What do you think?
Well, what I saw is already a big crisis for nitrogen since because of COVID, I think.
Yeah.
And yes, you can see that all the industry of liquid gas is having problems. I don't really know why. I know that it has a big issue. I know that, for example, Plastic Omnium, which is a very big company in France, they had to force their own workers to stop 1 week. Like they forced them to take a vacation because of
Mm-hmm.
this type of crisis. Well, maybe not ethylene gas, but some material leak problems. I'm not sure about ethylene. I know that all this strategic project was to kind of be insulated about ethylene word, but yeah, I assume that there's many problems regarding many type of gases or materials that are contributing into this bad industrial phenomenon.
Yeah, activities. Yeah, of course, some global issues, and we've seen, like, for example, that you've been involved with several industries and activities, and I mean, more or less like these companies, offshore companies. But I wanted to ask you what do you think of, for example, when you were talking about what I mean, and the final stage of the presentation, how do you think like mechanical engineers, chemists, and civil engineers do? Which is the best way to articulate their skills to finish a job? I mean, has it been like a little bit difficult for you to work amongst like um, uh, um, multitask groups? Yeah.
Thank you for the question. Well, honestly, of course, at the beginning it was a little bit difficult because I come from a very different background. But honestly, you don't have like there's no background for this work. Well, at least in France, you can be I don't know, method engineer. You can be well, civil engineer is still a little bit far. You can be plastic. We call it plastic material engineer, but there's no training or real classes to do what the job we do. That's why they accept different CVs and different profiles, and you have to learn that. That's the only advice I can give. It's hard. You will get well at the beginning. You absolutely have no idea about technical issues, but then you just ask your superiors, your colleagues, and that's how you learn.
Yeah, she should be like someone who takes all the decisions afterwards, right? Like, yeah, someone very
Yeah.
skilled.
Well, basically, most of our site manager they don't even have degrees because they started at a young age.
Mm?
Specifically, 30 years
Wow.
ago, people didn't
Yeah.
really need. So yeah.
Wow. Amazing. Thank you very much for your answers. There are a lot of questions for you around here, but I think well the time is as short as it shouldn't be, right? Because it's we would like to be hearing you like for hours and hours, but unfortunately it's not possible. And several questions we'll try to share with the those questions to you on different. I mean, maybe it's from email with email by email or something. Maybe you agree with that.
Yeah, sure, no problem.
Thank you very much. Well, finally, let us share with you this acknowledgement, please, in terms
Uh,
of
Thank you.
you too, you too. Let me share with you. Yeah, this is it. This is it. I will try to read in Spanish. I will read in Spanish. This is says like that. La Universidad de Guanajuato otorga la presente constancia a Doctora Lama Omar por impartir la conferencia From a Lab Scale of Material Synthesis to Their Application in Operational Projects durante el 13º Ciclo Internacional de Conferencias de Ingeniería Civil. Innovación, Desarrollo y Sustentabilidad en la Ingeniería Estructural, celebrado del 25 al 28 de octubre del 2021 en el campus Celaya Salvatierra, Celaya, Guanajuato, a 25 de octubre del 2021. Thank you very much, Dr. Lama. You're very welcome anytime,
Thank
any
you,
other time.
Hiram.
Thank you for your time. Dr. Marcelino, would you like to say some final words or some final statements?
Yeah, I was looking for my microphone. Dr. Lama, we would like, well, I would like, and we would like to thank you for your intervention, for your speech, for your words, and we will be so glad to have you probably another time. It was really great to hear you, and we wish you the best. Thank you for your time, and
Thank
like
you.
Dr. Iram said, well, this constancy is for you, for your participation. Thank you very much.
Thank you. It was a pleasure.
Thank you.